So guys, let's begin with the program. For this we have to put a percent value and what we have done, the power calculation. For power calculation, what we have a input as a velocity. So to import the velocity, we are having a syntax as xlx read, and we put a name for our drive cycle, that is FUDS, means Federal Urban Driving Schedule. So we will importing a drive cycle in our program, then we will mark this velocity as a V and extracting a component from this velocity as a in terms of time. Velocity and time. So as you see, this FUDS cycle having a two column. In first column there is a time, and in a second column there is a velocity. So we are now mentioning a velocity, so we have put here a velocity for this as colon comma 2. So here we are having a velocity that we are putting down. Then the velocity is in miles per hour, so we convert it into the kilometer per hour, as we have converted already in the Excel sheet. Then the n means length of the matrix, that is length, that is V. Here in this syntax we are having a length of this matrix, means we read this V in terms of matrix, that is column matrix. Then we have to put a mass of the vehicle, in kg. So mass as small capital, mass is equal to, what is our mass in this? We are considering a gross vehicle weight as 1200 kg. Okay, then we are putting a frontal area in square meters. So we are mentioning frontal area as area is equal to what is its value? Its value is 2.4 meter square. 2.4 meter square. Okay, then we are having a CD, means coefficient of drag. So CD is 0.4. So we will mention it as coefficient of discharge. Okay, then we save this value again we have to save, this value we have to save. Then we are having a air density. Air density as a row value, that is 1.225 in kg per meter, kg per meter cube. Okay, then have to save this value. Then we have a ratio, that is gear ratio. So for the manipulation, gear ratio, is in gear ratio is what we have done, 10.83:1. So 10.83 slash, we are giving a tire radius, because here we are manipulating a program in such a way that we are considering the means what, the 2 pi nt divided by 60. So we required that width ratio, or for the power there is a formula, that force into velocity. So for the velocity purpose, or for the torque, we are having a formula, that is force into a radius. So for that purpose we already selected or already multiply it by a gear ratio, so we can get directly the value as in a terms of for the motor. Then we are considering accessories power, that we can note as PAC equal to 100 watts. Watt. Okay, then a transmission efficiency. So the losses which are coming from the gears, axle to the wheel. So for that we are using a transmission efficiency, that noted as G underscore EFF equal to 0.95, it has no unit. Then we are considering a motor efficiency, motor, that is equal to 0.80 have to save this value. Then now for initialization of the variable, we are putting all the variables into a one metric form. So for that, initialization of variables, that is the end, means distance at the end is zeros. Zeros is the syntax for the null matrix, and as up to the 100. Then we are putting power of battery equal to zeros as 1, n. So this is the length of our velocity. Then d, then the p. So friends, here we are putting one factor, that is regeneration. So for the regeneration value, we are considering this regeneration as 100%. But whenever we are doing a practical calculation, we have to calculate this value from our motor or idle power, that when we release our accelerator pedal and remove our foot, at that time what energy we should generate from the reverse of the motor is called as regeneration of that motor. So we have studied regeneration braking in our course, so I will not go into the deep. Now I will put P regeneration, means power regeneration, is equal to zeros 1, n. Then I will record a distance travel in kilometer. So distance travel in kilometer is equal to d into zeros 1, n is equal to n. Now E battery means energy of the battery. Also we are giving this is also into a matrix format. Then the total power, PTE, that is total power, we are also putting this into the matrix format. And the all the so for we are doing this for our one cycle. So Cy is equal to 1. Here we are putting all the inputs, means what we require. We required mass, frontal area, air density, gear ratio, efficiency, and all that in a same format. So in our next chapter we will see how to put or how to manage a program to find out various types of forces in it. So we will see you in a next chapter. Thank you.